All right, so this one, the second graph, this one, it is a straight line. You might say, how is it a straight line? Because what's in the box must be simplified. When you simplify that right at the top, you can factorize this difference of two squares. Can you see that? It's x minus 1 into x plus 1. And then it will be all over at the bottom. It will be x minus 1. So you can see x minus 1 cancel. What remains, it's actually x plus 1. And you do know x plus 1 is y equals to mx plus c, equation of a straight line. When I want y-intercept, put 0 by the x, y will be 1. There it is. If I put 0 by the y, transpose the 1, x is minus 1. So minus 1 into the graph will go through there. But remember, when you're dealing with rational, with division, the denominator can never be 0. So x minus 1 must not allowed to be 0. So that means x equals to 1. It's not allowed. So we're saying x must not be 1. So that means the value of x, when x equals to 1, we can't use that on the equation. Are we together now?
Yes.
It's an open circle. So that means just substitute 1 here in the equation here. When you put 1 here, if we're to really put 1, you're getting 2. So that means coordinate 1 semicolon 2 must be removed, because it was here where I'm drawing the red line, where there is a dot there, where I'm shading the dot. So that has to be an open circle. So that means if we're to write f of 1 of the graph, it does not exist because it has been removed. The function f of 1 does not exist, but that does not mean the limit will not exist. I was just showing you the graph was correct. That's all I was doing. Are we happy?
Yes.
All right. So now let's do the limit approaching this. In other words, I'm looking at the x value. The x value there is 1. There it is 1. So that means I'm going to write what will be the limit of f of x, that equation, when x tends or approaches the 1. Remember, this is graphically, because sometimes you are not able. What if there was no equation? How will you get it graphically? All right, so what we do, let's work with limit coming from the left-hand side. So coming from the left-hand side, approaching that 1. All right, so I'm going to use dot. The first red dot there, I'm going to look above and below it. Where is the graph? Well, the graph is above. So that means if we're to do this, the value will be read here by the red dot. Are we happy?
Yes.
All right. Then I'm approaching a little bit more. I put a black dot there. Where is the graph? It's above the black dot. That means it will come here. And then I'll read the next value there by the black dot. Are we still together?
Yes.
All right. Then I put on the green one. I identify where the graph is above or below. Then I come there and I go there. Then I can see. So you can see everything that's happening is going towards the 2. Are we happy? All right. Good. So now you have identified that as you approach x, 1 from the left-hand side, you are approaching 2. So that means I can now write the limit as x approaches 1 from the negative side of that equation, f of x, we're getting an answer of 2. That's a left-hand side limit. So we want to do the right-hand side limit. Right-hand side, that means now I'm coming from the other side of 1, following the red line. Is that so? Good. So now let's start. If I were to put a dot somewhere down here next to that x here, then I identify where the graph is. Well, the graph is way above there, so it's going to be somewhere there. The corresponding y value will be there by the purple dot. Then I said, well, let's bring the dot, the x closer. I make the black line, the black dot there. Where is the graph? It's way above there. and then it's going to come there. So you can tell it's coming closer to 2 as well. Are we together on that one?
Yes.
All right. Now, what I want to say is this. All right, the red one, identify limit coming from the right-hand side, and that red, it tells you what the value is. So now I can write limit of f of x as we approach x. I mean, when x approaches 1 from the positive side, we get 2 as well. Left-hand side and right-hand side are equal. Can you see that? Am I right?
Yes.
So now we can tell them that limit, you have to write that statement. I'm not writing now. You must just know, you must say limit of this one, left-hand side equals to right-hand side, they're all equals to 2. All right, so then I can say limit of f of x as x approaches 1. The answer will be 2. Now, I want to state something that I wanted to say here. Watch now. Even if the function value, remember, when x is 1, the function value does not exist. Can you see that?
Yes.
Yeah. That doesn't mean the limit does not exist as well. That will have to do with condition of continuity, but we're not doing continuity because there are 3 conditions for something to be continuous. The function value must exist, the limit must, left and right must exist, and then the limit must be equals to the function value. Those are the 3 conditions, but I'm not there. Yeah, so even if the function value does not exist at that point, the limit can be the value at that very point that does not exist. Are you happy with that one?
Yeah.
All right. Because why am I saying that? It's because normally when we do the limits, let's just go somewhere here. Let's go somewhere here. I want to just go here, somewhere where there's questions. Like here, for example, here. Because we're going to tackle this one. This is where you do the question. So, to get the limits, all I need to do is to do direct substitution. Am I right?
Yes.
Good. But sometimes when you do direct substitution, you find that it does not exist. That does not mean the limit does not exist. That's what I'm trying to tell you. Because most of the questions, when it's if you are given equation, you just do direct substitution, and then your mind thinks, well, to get the limit, I must just substitute. If I find the value, there it is. If I don't find it, it does not exist. But that's not always the truth, because I'm proving it here graphically. The f of 1 does not exist. so that means if you were to put 1 here, you put 1 here, you're gonna get undefined. And you're like, how come I'm getting undefined? Here you're getting an answer of 2. They don't have to be the same, because you'll have to simplify that. Did you understand everything I said? I gave you those key. Am I right?
Yes.
Yeah, because that is just one of the theories. They will ask you, if the function value does not exist, does that mean the limit does not exist also? No, not necessarily. All right, here it's exactly the same thing to sketch this graph. I'll show you how to sketch these multiple graphs here. But here it's exactly the same idea. We can do limit as x approaches 1. But in this case, they told you here the function value does not exist there. It only exists for this one here. That means when x is 1, the y value will be 1. So it's that point there. So let's put that one in red, and then I'm gonna have to pass here, because I think now you now understand. Now that is the function value. So I'm just telling you, f of 1, your answer will be 1. But that does not mean that will be the answer for the L, the limit. No, it doesn't have to be. It doesn't have to be. So when you approach 1, we have seen it because it's similar to this one. When you approach 1 from the left-hand side here, you can tell, because 1, you'll be actually going towards the 2. I'm just doing it straight now, because now you understand. Coming from the right-hand side, you'll be approaching 2. So the limit is 2, but yet the function value is not the same as the limit. Can you see that?
Yeah.
Yeah. That's what I wanted you to understand. The function value, it's not always necessarily equals to the limit. But most of the time, I can say 90%, yeah, it is so. They're actually equal. So far, so good. This one, I think we are good.